I'm going to review some notes that I took here and the small scaly draw thing that I did here. And after that, I'm going to step over the editor's code. I'm going to try to go fast because there are some really annoying parts. I have to remove a bunch of breakpoints because at some parts that Godot's loading the shaders and uh, building the pipeline on Vulkan, there's a bunch of loops, and then it takes a long ass time to go over all of them if you have breakpoints. So I might have to remove more breakpoints. And I think I'm just gonna go over the editor's code and I'm gonna try to see if I can. I still don't understand very well how it works. I spend most of the time recently trying to understand how how they use Vulkan to build the graphics pipeline. So I still don't understand very well how it works. So I'm going to run the executable here, and first I have to see what is the command that I'm using on the launch.json file. Let's open here. Just see what executable I'm running. So I'm gonna run this executable here. Then I'm gonna go over the code, then comment some parts out and see what happens with the GUI. That's what I'm interested. So I was trying to understand from the bottom up how the graphics work, but I think it's just too hard and too confusing. Like what makes it very confusing is all the inheritance on classes. So I think I'm gonna try today the other approach, which is top down. So from the GUI elements to try to understand what is going on. I'm probably gonna go back and forth until I figure it out. I'm gonna put the timer here. The thing is, I stepped over the code yesterday, and I think 2 days before, and there's just a lot of stuff. It's very like the part that is not related to the shader to the pipeline is kind of easy to understand, but the part that builds the Vulkan pipeline is very confusing. And I think it's just a byproduct of Vulkan because Vulkan is a lot more complex than OpenGL. And like the main thing that I'm trying to understand is how the shaders, how they are selecting the shaders, but I couldn't figure. I got to the part where they cache the shaders. So as far as I understand now, the first time that you run, actually, I think it's probably the first time. The first time that you run, it checks to see if you have shaders cached on a certain path. And if you do have them, then it's just gonna load those shaders. I also found that the thing is, I don't know very well the exact paths how the command line arguments work. So if you don't put any command line arguments when you're running the executable, or actually when you're compiling the executable, it's just gonna run the project manager first, which is the GUI elements that select what kind of project you have. But if you build the initials of a project and you save that project, then Godot is automatically gonna save that on a file for you. And in that case, when you compile the executable with additional RDATs, tell Godot where the path is at, which is just a flag variable that I have there that I realize now. So there's the main setup function, which is the function that sets everything up. And then there's the main setup to function, which is an additional function to set everything up. And whether it runs that function or not is based on a flag variable. And the flag variable just checks the second argument that was passed on the command line. I think it's on when you're executing the program. It's not when you're compiling. So if you pass an argument when you're executing, then the flag is probably going to be true. I'm not 100% sure what kind of flag it is, but I know that's going to go when you're debugging the editor directly. Is going to go over the main setup true function, and then that's the function that is going to load the GUI editor directly instead of the project manager. And there is some stuff there that I don't understand very well yet, but it gets a path where the project is saved, which is not the path that Godot usually uses. So Godot usually saves everything on the app roaming. App, oh, C users app roaming, I think, or something like that. And I'm not, this is a part that I'm not 100% sure, but I think that when you run the project manager, it's just going to create the file on a standard path on Windows. So it's the C users, then your username. I think app data is the thing. Yeah, app data, then roaming, and then the Godot's name. So it's C users, app data, C users, your username, then app data, roaming, and then the Godot. And then here, as far as I understand, and it's interesting that I realized I was searching some stuff before, and I think I searched something, then a video related was recommended, which is the 10 most successful projects on Godot or something like that. And then I realized that one of them, because the video says, I think is the second one, the most successful, is Turing Complete, which was a game that I played before to try to understand how the logic gates, which I highly recommend because it's a very good game, how the logic gates are used to create the computer. So you basically create a computer from scratch using logic gates. It's very good. And I just realized that it was built with Godot actually. And if I remember correctly here, there's some part here, I think it's on the here. So this I'm pretty sure is not related to the project that I created, which is just a simple project to see what Godot does or how Godot works. So the name of the project, if I remember correctly, is Experiment, and I think I created another one by mistake. But this is probably the main one. But you don't save actually on this path. You save on another path when it's asking you where to save, which you can select. But I think that it's gonna automatically save on both places. So the standard path is this one, where Godot actually saves everything, and it probably saves for all the games since I saw this stuff here. And all that the game is just data specifications of how the engine is going to work. So any Godot game is always going to run the same engine, but then what changes between games is the kind of data you are using the engine with. And that's what gets saved, I think, when you export. I also found the functions that have they're related to export there, the classes, but I still don't understand very well. But as far as I understand now, I think that the editor is just a node. So the way that it works is that you have the main loop, which is you have the OS, which is an abstract class that is going to determine what operating system you're using. And then from that, you're going to inherit, depending on what kind of OS you're using. I'm using Windows, so it's going to be OS Windows. Then that OS Windows is going to initialize, either it's going to initialize the engine or the engine is initialized outside. And either one of these classes has another class, which is called the main loop. And the main loop is the thing that is actually used to run the game loop after it sets everything up. So I forgot what I was going to say. Is inside of the main loop that you have, there's going to check to see the flag variables that you compiled or initialize or run the executable. And depending on the flag variables, it's going to run either the editor or the game you saved. But I forgot exactly what I was going to say. Oh yeah, the sync tree. So the main loop class has, I don't remember the connection very well, but there is a sync tree class, and everything on Godot is a sync from the engine's point of view. And the difference between each scene on the gameplay is that each scene is their own subtree on the main tree. So when you're changing scenes, you're just changing the subtree that is currently the child of the root tree, as far as I understand, the root node of the whole application. So the editor node is just one of this, it's just a subtree. So it's a main node. And then from the editor node, all the GUI elements are added inside of the tree. So so you can imagine that you have the overall GUI element, and then inside of the GUI element, you have spots, for example, for selecting something or writing something. And then each one is a child of that node. And then that node is the child of the editor. And you're basically just creating a tree. So as far as I understand, it's like that's how it works. And then In order to determine what happens when you interact with each part of the GUI element, you subscribe the thing, use a thing called signal, which is just the way that that Godot handles events on the engine. So you subscribe the classes and the functions for the GUI elements. And this part I don't understand very well, but I assume that that's what's happening. And then you can tell whatever's going to happen from that. So one of the main things that I'm interested in is trying to understand how the export thing works, because, and it's kind of confusing because of the paths, because I want to understand, as far as I've seen from the high level, people recommend when you want to export your game, when you're on a distribute your game, what you have to do is just click the export on the GUI. And I want to understand how this works, because I want to understand what exactly is the final game. And as far as I understand, it's just running the engine with data, with specific data that is related to the game. So both, I have to understand both the pipeline. I already understand some Vulkan concepts, which is kind of confusing. And I thought about a good analogy, which obviously they thought about it as well because of the name that they give things, but it's kind of intuitive to understand. Like on the conceptual level, it's very easy to understand how it works, but then on the specifics, it's very hard. So basically, the way it works is that you imagine that you're building either a billboard or buildings, and then you have a construction site around those buildings, and the building is the final image that you're going to show to the user. And you can have as many buildings as you want, and that's called the swap chain. So each building in this analogy would be an image, which is the thing that you show to the user. Then you have the lanes. The lanes are the queues that you have. And each lane has cars or trucks or whatever, different things that you can use to transport data. And those are the command buffers. And the descriptors are the difference in cars or trucks that you going to use to send data. So it's just a specification of what the car looks like. And the car is just the command buffer, this knowledge. So you have the cars, which are the commands that go on the queues, which are the lanes. And then on these queues, you have semaphore and fences, which is just the thing that you use to synchronize the traffic. And all this traffic is just cars moving the data, which is the necessary stuff to build the building, to the image. And then you also have pipeline barriers, which I don't understand very well, but is also related to the synchronization. And imagine it's just the same thing as the fences and semaphores, but it's for the final step, which is the pipeline. I don't remember I don't know how I think it's sub render pass and render pass. Yeah. So the final stage is the sub render pass and the render pass, which is the stuff that is actually going to draw on the image. And the analogy breaks down because on the swap image, on the swap chain, you're actually just showing one building, and then it's kind of like you're swapping the buildings in a loop, for example. So it's iterations, so you can dynamically show to the user the construction of the building like in a smooth way, instead of having to use the double buffer technique, which is you would build the entire building and then swap buildings. So all that the user see is the new building, and you're just using the other buffer to build. But when you have more images, the minimum is 2, but you can go up to 8, I think, or something like that. You can have several different buildings, and then instead of swapping directly, you're swapping on a gradient. So it's just like the evolution of everything. So you're going from a binary into the gradient, which adds more complexity. And I think that's the evolution of everything. And then as a consequence of this, most of the complexity is on the synchronization and on the specifications. So the descriptors are similar to GL, attribute vertex, and this other stuff where you can specify how the vertex data is going to be used, which is the command buffer. And the texture stuff, you have a sampler, I think. You have descriptors that are related to sampling, which is the stuff that you use to determine what kind of parts of the image you're going to take. And also, there's another distinction on Vulkan is that on OpenGL, we have to specify different buffers if you want to load the 2D image or 3D image. And as far as I understand now, on Vulkan is all one thing you use, and then the difference is going to depend on the way you structure the data. So this kind of is more complicated. And then on Godot, the part that it gets to this point They use another library which is recommended to use, which everyone uses, I think, because on Vulkan you have to compile the shader code from .vert and .frag into an intermediate representation, which is spurv. Don't know how to say that, but is the way that is the format that Vulkan understands to compile everything. So use this other external library, and then there's a bunch of loops because there's a bunch of shaders to be loaded, and they cache all the shaders at first, and that's what makes it harder to understand what exactly the shaders that Godot is using to draw the editor, because they cache everything at first on a loop, set everything on the whole pipeline, and then on the higher level on the editor, all that you're doing is just inside of your functions calling the APIs, which is the interface from the engine, so that the APIs select what's going to happen on the pipeline. And the difficult part to understand this is because there's a bunch of classes because it's a object-oriented paradigm, so basically the way that everything works is that you have base classes for everything, and then those classes specialize themselves depending on what kind of operational system you're using and what driver you're going to use. And that's where it comes most of the complexity, and then it's kind of annoying to understand because when you're using C++ and you're stepping over, not only you have the loops, but you have this thing where like one abstract class is initialized on some place, but actually is gonna use the derived class, even though the type is from the base class, and it has to be that way because it has to be generic to work. It's kind of confusing. So yeah, I think what I was going to show is the export here. No, it's not. I think it's only, yeah, it's probably a project export. This is how people recommend should do. And then I got this error here, and I think this error is because of the paths. So this is another very confusing thing that I don't understand how it works yet. Probably one of the most annoying things for now. But yeah, I'm gonna step over and try to comment out to see how the interface changes. Probably the main thing is gonna be actually I need to look at your task.json because that's the one that compiles. The main thing is gonna be the export, the shaders and the export to understand first. So to compile, I'm using scones and then passing dev builds, yes. So let me go over the notes here. It's all over the place because, like I said. So probably I'm gonna go over SketchDraw first because this is one of the parts that I'm kind of clarified now, but there's still a bunch of other stuff that I have to understand. So basically the way it works is that you have, I don't remember exactly the nuances on the levels of everything, but mainly you have instance, and then you have the physical device, and then from the physical device you have the logic device. And after you set up the logic device, you interface with everything else through the logic device. So the logic device is the thing that manages physical devices, I think. And physical device is just the GPUs on your computer. So I found the function that they use to select. They select based on a score that they get. And this is another confusing part because they create another struct that isn't directly related to Vulkan when they're initializing the instance. And then that struct creates the holds information for the physical devices that you have. And then later on when they're initializing the rendering device, I think, they loop over the physical systems from one of these classes here. And that's how they select which one they're going to use as the main one. And it's through a score. Then after they select that, there's another confusing part, which is that they are going to initialize everything on the rendering device driver, which is an inherited class, if I remember correctly, from the rendering context driver. So rendering context driver is the abstract. Actually, no, it's derived from rendering device. Yeah. So they're related in aligned here somewhere. I think this is initialized calling this function. No, this is initialized here. Yeah, when they initialize the display server windows, which is sets up in the beginning, it has inside of this class here this rendering context variable, which is just an instance of rendering context driver. So when it initializes this, it's going to initialize this at some point. And here it creates the instance, and so Vulkan instance is directly connected with this one. And the surface, which is another Vulkan thing that is used to draw the final image, as far as I understand now. I still don't, I'm not really sure about the surface yet. But yeah, it connects them through this variable here. And then later on, it's going to pass this inside of a function, this rendering context, which is the rendering context driver, as a context. And then it's going to call the function from this class here, which is driver create. And this function creates the memory of this class here. It returns the creation of, which is memnew, which is a customized way that they allocate memory to create a class. So it calls this function, and that function returns the initialization of the class, and is storing this here on the driver member variable of the rendering device. So it connects them this way. So yeah, the rendering context is this variable on the display server, and the rendering device driver Vulkan is the driver variable on the rendering device. And the reason, again, why they did it this way probably is because it depends on what kind of system you're using. So this is the generic template of how all the systems are going to follow, like the logic. And depending on what kind of driver you're using, then it's going to specialize on the subclasses, on the derived classes, which are this one. And on this one, it has most of the functions that set up everything on Vulkan. So each physical device has a queue family, which is the lanes that I said. And then you have the command buffers, which is the data that you're going to allocate, and the descriptors, which tell Vulkan how you're going to allocate. And the other thing that is that they use a helper library to also interface with Vulkan. So it's very similar to OpenGL, where OpenGL uses gl.age, which is just a massive file, header file, with a bunch of pointers that allow you to communicate with the API. And Vulkan is pretty much the same way. It's slightly different, but it's kind of the same idea, where you have a bunch. They use a external library which has a bunch of function pointers, and then they subscribe one of these classes here with the library. So this class has a functions data structure, and that functions data structure is gonna connect with the external library from Vulkan and get access to all the Vulkan functions, pretty much. I think it's this rendering device here. Function that selects physical device is rendering device initialize. It uses the context created. Yeah, so the display server creates the instance, and the physical device is created by rendering device. And this is the thing that makes it kind of confusing, because when you're studying Vulkan on its own, based on the tutorials that I've seen, it's kind of like everything is like part of the same kind of thing conceptually. But here, each class is going to construct a different part of Vulkan, and then it makes it kind of hard to understand how they are connected. But it makes sense, again, because of the specialization. It's kind of just a byproduct of the way things are, I think. And I wrote down here, so this is the loop inside of one of the functions that they use to select what kind of device they're going to use. It's based on this function here, and then they get the score. I don't know. I didn't dive too deep into this because this part is related to the initialization of display servers. So it's kind of confusing to understand. But that's how they select. Then they use this index on the other functions to initialize the physical device through the Vulkan API. So I'm going to step over there. Let me see if Vulkan instance initialized on display server Windows. Yeah, display server is just another thing again, where the display server is going to be the base class, and then depending on the OS you're using, it has derived classes for each OS. Vulkan surface created inside display server, went to window, render contacts. It's saved on display server, but the Vulkan surface is saved on rendering context driver. How is rendering driver initialized on display server window class? It calls the Vulkan functions from rendering device Vulkan. I'm gonna initialize the thing here. I'm gonna press, hopefully I have like the right breakpoints there to go faster. I had to remove a bunch of them, like I said, because of the loops. It calls the Vulkan functions from the rendering device driver function registers the struct created. So the annoying thing is that they connect the functions on the display server with the rendering context driver through a macro. So there's a macro that initializes a struct inside of the display server class, if I remember correctly, the display server windows. And then they usually return the initialization of the macro on some of these functions after they initialize everything on the other class. So that part's kind of confusing. So, and I think that the reason why they did like this is just because they didn't want to repeat a bunch of unique class initializations. They use a token paste operator, which is the double hashtag thing that is just going to concatenate your different tokens to create a unique name. And they put that inside of a macro to initialize a struct with a macro. And maybe they did this because of the optimization, because I think that they put inline, which means that the compiler is just going to paste the codes or something like that directly there. It calls the Vulkan functions from the rendering device and registers the structs. Yeah, they are linked by define ID, so this is the macro it's talking about. Initialize a struct is a macro, kind of weird. Render device, as like I said, I didn't like that much because it makes it more confusing to understand, but I'm sure that there is an explanation for it. Render device graph, this is also another confusing part. So I don't know very well why they are using this class, but they are using another class to build the pipeline. And I think that the reason why they use another class, which is this device graph, is because Vulkan is complicated. So this rendering device probably creates a tree where it's just the thing that is used to set up all the synchronization that is going to happen, I think. And like separate the commands and stuff like that. But it's kind of confusing. And then they select Vulkan there, on my case, because I have the driver. And there's other options. And the default method that they render is forward plus, which is another thing that I don't understand very well, but there is a page on the documentation where they talk about this. So there's different ways to, and this I think is going to be relevant on the render pass parts. So there's different ways to render everything, I think. So I guess the forward plus is probably you render everything first and then you show, or I don't know the difference yet. But forward plus is the default that they use there. You're using third-party Vulk. Yeah, this is the library I was talking about. So they use this library. This is the equivalent of gl.h on OpenGL for Vulkan. And they also load a bunch of DLL libraries to do a bunch of things. The Vulkan itself is a DLL, so it's the exact same way that you load OpenGL. So you call a Windows function which loads the DLL, which is the dynamic linked library. And this is how I think most of the software works on Windows and is in order to optimize compilation time. So a dynamic linked library is just a library that's going to be on some other part of memory. So because the operational system divides everything into processes, and then it allocates memory depending on the processes. So the dynamic linked library is going to be on a different part than in. I'm not really sure if it's on a different process though. Maybe it's a child process, something like that, but I'm not really sure. But I know that it's on different parts of memory than all the other parts of the program are. And then it's kind of like you're injecting that into the program every time you load the dynamic link library. And then there's some security risks because someone can like hijack that and change the functionality of your app. But I have to study more about that as well. The name of the first shader to be loaded is this one, canvas shader. I think these are all notes from before, so that's probably all that I wrote so far. So we're just gonna stop there. I skipped the main setup, but this is the setup function. It's gonna initialize everything. I'm just gonna press F5 and see if it's gonna stop on the parts that I talked about. Because I don't want to go with F10 and then spend a longest time to see everything again. This thing is kind of confusing as well. Because there is this macros, and as far as I understand now, they're used to register on the database, the classes. So it uses kind of like this is like an internal tree structure that's used to manage the folders of everything. And I think this path represents just classes or things like that, or variables. So you load everything on a class DB, which is a class that holds the data that is used by the engine and the servers. And you register them or get them through this by passing the relative path. But it's kind of confusing to understand what's going on there. I'm just gonna press F5 again. Yeah, this is the module that is an external module, and this is the module that is used to compile the shader code from the shader extensions. The normal way you would use the shader on OpenGL, have to use this additional library here. So it's kind of like the equivalent of calling GL compile shader, but it's different obviously because you're compiling to this intermediate language here. Maybe I should open the files as well to see, just to look at the. Oh yeah, the first time that it runs, it also caches everything. So this is also done on the other directory, which is the relative directory that you save the project. Let's see if I can find here. Which is you that selects where it's gonna be. So in my case, I put here on the same directory that I had Godot here. Also found this Godax here, which uses it's Godot but using the entity component system. And the main difference is that, like I said before, everything on Vulkan is gonna be this abstract base class, and then it's gonna have inheritance. So this is the object-oriented paradigm. But if you use composition, then you have different classes, and then you compose classes based on each other. So I think usually you do either a member variable or dependency injection, things like that, where each entity can have as many components as you would like. So is it just a different paradigm? And it seems that it is better for things that require a lot of data. So I am curious about how it works, but it's gonna take a longest time as well to figure this out. So I think I'm just gonna focus on Godot first. So I saved it here. So this is pretty much the same. So it's just saving on different parts here. Yeah. So experiment. And there is a part of the code there that's it shows some of these paths, but here I think it does have the shader cache as well. So the first time that it runs, it's just gonna compile all the shaders that you're gonna use through the entire project, and then it's gonna cache them. And then the other times, obviously, checks first to see if the shader was cached or not. If it wasn't cached, then it's just gonna cache all of them into this paths here by using a hash algorithm that they implement there. So here it saves on a different path, which is kind of weird, but I think here it saves on a different path because it's related to each local project, and because it's gonna save all the Godot projects you have on your computer on the same path probably. And it has to separate the cache for each project. I think that's what makes the most sense. Just compiling everything and saving in these formats. Yeah. And this default driver, if I remember, is Vulkan. Yeah, you Vulkan. And it builds based on the macros here. The macros are kind of weird. Like Usually when you don't define something, it shows up as this like kind of faded way here, which should indicate that it's not running the code, but there are some instances where it's actually running the code, so it's more of an IDE problem, I think. Which makes it kind of confusing, but it's basically based on the flow here of the arguments, I think. It's just gonna push Vulkan to the thing, and then it's gonna use that to select. That's whatever. So this is the part that I was talking about. Oh, so this is true. So I don't know why this is true, because this here is passed on the function there, on the main setup function. And before is the way that it gets this variable is through the command line arguments on the main function in the beginning, when like on the entry points of the whole thing. So this variable is the one that determines whether or not, and this variable is only going to run if you're running the editor version. So otherwise it doesn't do this, and it goes directly to the loop there. So the setup true, I think, is just related to editor stuff, the editor setup. Ah, whatever. I'm not gonna show there. Oh, the thing that is weird is that it initializes the display server on this thing here, which I don't understand very well why that's the case. So the display server, the function that is used to create, I'm gonna go back actually to show this stuff, because it's, I don't remember exactly what function, but there is a function there where it's gonna register which function is gonna use to create the display in the beginning. And then based on what function it is, it's just gonna call that function to create the display, and is on the display constructor that is gonna initialize the Vulkan instance and the context, if I remember. Yeah, the rendering context. So it's kind of confusing to me why it doesn't have this function on the other one. Maybe it does have, but I missed. Because that would mean that when you run the project manager directly, it's not using the display server, but that's not possible because it has to use the display server, I think, to do everything on the pipeline. Oh, fuck. I meant to press F11 there, press F done. F11 you step into, which goes inside of the function, and F10 you step over. Which if you don't have breakpoints, just gonna skip everything that the function does. So I'm gonna put the breakpoint again here. So this is the thing that I was talking about before. As on this one, see here it's kind of confusing because I'm not very familiar, but like it puts this function here because that's the Windows entry point main function. So when you're compiling for Windows, it's just gonna start the whole application to this function, and then it calls the main here. But then the weird part is that it gets the arguments in a weird way that I don't understand very well. You're just skipping this one and going here. So here is supposed to be argc is the amount of arguments you pass when you're executing the program, and argv is a pointer to a string. So a pointer to a pointer because a string is a char pointer, which is basically an array of strings with the arguments that you pass when you initialize. But it's not passing this directly here, which is kind of confusing. So this function calls this, but then it's going to parse the arguments here. I guess it's so it's passing here, and then this is the main. This is the function used to parse the arguments. So each one of these is one argument you pass on the command line, which is usually the parameters you pass along with the executable. So the weird thing here to me is that, like on the other function, it's going to select whether or not he's going to call main setup true based on their arg1 thing, which is the second argument you pass. But when I'm launching here, the debugger use launch.js of VS Code to launch the debugger. So first it runs task.json, which is going to compile, or it's going to run whatever command you put here for the task, which is this one. Oh, actually, I forgot. Good thing that I remember now that I'm actually using this one to run the command here. So yeah, but I guess it makes sense because it's probably going to be, actually now that I think about it, it does make sense. So I thought that the second argument is going to be this one, target equals editor. So it doesn't make sense for the thing should be true there. But now that I remember is that I'm using scones to compile. So on scones, they have the build system, which is the file there on the root, and the file is going to have a bunch of Python code that determines the compilation process. And that file, now I remember that it has some stuff related to the editor. So it's probably here that they put the logic. So if you put editor equals yes, it's going to check to see if that's true. And then it's just going to probably put true there, maybe. But that doesn't make sense because it should be when you're running the executable, not when you're compiling. Yeah, so I'm not really sure actually. Let me see. Because I think it doesn't make sense for the final executable. It does make sense for the final executable, which should be different. But this is a question is like how the executable would have the argument embedded into it. I think that doesn't make a lot of sense. So let me see on the launch.json. Launch.json is the command you're passing, but it wouldn't be. I guess it depends on actually how it parses the commands. Yeah, but the parsing, if I remember correctly, comes. I'm just gonna see there. Because I don't remember exact. From what I remember vaguely, the parsing of the command line arguments passed when you're calling the executable is after the setup. So after the main setup true there. Because obviously the argument, the variable there that selects whether or not it's gonna run the main setup true is true, but the value of the variable, but I'm not passing true in either of the arguments here, so that's the confusion that I have. How is it possible? But obviously some logic either on the build system or before the setup there that is doing this. But I'm not gonna spend time on this now. So let me just go over here. Oh, it's calling the other one. It's weird. So I'm pretty sure it's this function here. I'm gonna put breakpoint. Yeah. So this is the function that is gonna register in the beginning. So assume that I haven't seen the code for the other platforms, but I assume that they are all gonna do the same. So each one has a derived class from the display server, depending on the OS, and this is gonna have this function which registers the Windows driver, which is the function that is gonna use to create the to initialize the class, which in this case is this great func here, and is on the constructor of this class that initializes the Vulkan instance. And it's gonna run this on main setup too, if I remember correctly. So this is what I was talking about. So after it parses the arguments from the wchar uh, formats of strings, converts them to UTF-8, I assume on this function here. I haven't looked into this, but I assume based on the name that that's what's happening. And here is going to be the second argument that it parses. So this is the stuff that I don't understand very well, because the second argument should be the -e there, because I'm running the executable from the launch.json with the debugger, and the second argument that I'm passing is the /e. But if it is /e, then it doesn't make a lot of sense. Should be so it looks like it's just the path actually. Hmm. Yeah, this would make sense because if you don't pass the, I try to debug without passing the path as an argument, and then it doesn't work. So you do have to specify the path because probably Godot's going to use the path to find the data related to the application, which is the engine is going to use to create the game or whatever you created with the engine, with the editor. Or maybe this is something else. But if I remember, this is false by default. I remember seeing somewhere. That one that makes sense. Maybe I did like this. So it's true, but I don't understand really well. So here is probably it is a pointer to the first argument that I passed, which is /e, and the count is 3 because I'm so it is the obviously I think that makes sense. So this is based on the arguments that run after I execute the after I run the executable. So the arguments that you're passing on the launch.json. Hey, what's up? But I don't understand why this is true by default. It doesn't matter that much, so I'm not going to spend too much time on this. Hey, what's up? So there is a. So maybe it does happen. No, but that wouldn't make sense because it's true there in the beginning. So it has to be something that I don't understand that is going on. Like it couldn't be. Default behavior. So the thing that is kind of weird is because it couldn't be a global variable because it's being passed on the as an argument, but on the place that it calls this function, it looks like it's not passing this variable. So it should be false by default if it doesn't pass anything, or it should break the thing because it's not a default argument. Whatever. Let me messy, should be globalized. Yeah, whatever. So somewhere here it's gonna it has control flow to determine what's gonna happen based on the arguments you pass there, and the path is obviously the one that is gonna be used to determine whether or not you're running the editor or uh, the project manager, I think. Also, I think I'm not, yeah, I'm not gonna spend too much time on this. Otherwise, I have to just press F5. So otherwise, I'm just gonna get caught up on this stuff, and it's like it's very massive the amounts of stuff that he has here. Just gonna press F5 until I find something interesting. I don't remember now if I disabled the function that initializes the display server. Oh, so is this one. So this is the main one that is going to be related to Vulkan. Pretty sure is on the setup true thing. Yeah, setup true. So after you parse all the command line arguments and then changes some values of global variables, if I remember correctly, it's going to initialize the display server. So this, based on the comment there, this is the default. So which makes sense, because I remember the previous times where I just was debugging the project manager. It was creating the display server, but I didn't pay attention. So, but I think is the same line there. So it's always, I think that this is just, it doesn't run when you use the headless mode that they have there. And I think that the headless is the last default option last option that they check. So you can run the engine without using the GUI probably. And then when that's the case, then it's not gonna run the setup true, I guess. So yeah, this is the function that I showed there before, where selecting from, and it's doing like this because again, it depends on what kind of OS you're gonna use. So here it has to be generic because it doesn't know yet what kind of OS, but then because you register before, it knows that is the function that you register on the setup there. So it's just gonna use the display server windows, this function, which is gonna create the class display server window. And this memnew is the thing about the custom global memory that they do. Just a memory pool that they create to optimize the speed. So they create a pool of memory and then they manage the memory based on that pool. So they put everything on the same, or like on a continuous space, I think. Not really sure if it's a continuous, but it's just a memory pool, like a space that they customize and they decide how it worked. I think I talked about this before, so just I've been skipping the parts. Maybe I'm probably gonna go deeper into them once I understand all the other stuff, because there's a lot to understand. So is the create window there is gonna call this later, and it's gonna initialize the rendering context, I think. To call some Windows functions, if I remember. This is one of the annoying parts about stepping over this, because each class is gonna initialize a bunch of stuff, and then you have to be careful because you don't want to skip things by mistake, because then you have to go over the beginning again. So this is just registering everything based on, I think that the addresses or numbers that Vulkan uses to capture each key. Just creating this map. So we're just gonna over. And most of the things are singletons. So the singleton pattern, you create the class only once for the whole thing of the program. And the way that they do that is by creating a pointer inside of the class, a member variable that is a pointer inside of the class. Yeah, actually points through the instance of the class. So I think that what this makes is that regardless, but I'm not really sure about this. Like I was gonna say that regardless of how many times you initialize the class, you all that you're gonna do is just have different pointers to the same place in memory, and that's the point of creating the memory variable that is a pointer to the instance of the class. Because the idea of the singleton is to only allocate one space in memory, regardless of how many instances you have. If I, but I'm not 100% sure about this. But the idea is to have just one class for the entire program, and then you access the class with the get singleton thing. And then they're casting because the OS is the base class, like everything else, and the OS Windows the derived class. I just skip all this stuff. So here is the place that I put there on the scalar draw. So this is going to initialize the rendering device context for the first time. So it's using the same memory pool based on the thing, and then initialize this class, which is going to be, I'm not really sure if it's this one. I think it is this one that has all the functions to set up the pipeline. So it's jumping between classes like this, which is kind of confusing because the constructor of this class here has all the other classes as member variables. So when you step into, you just go to the other classes. They're the constructor of the member variables that the class has. Just gonna see if I can. And these other times that it does that, it goes to random classes because they are not using the standard string and standard vector and stuff like that. They create their own custom uh, classes. And because of the way that they set up memory, I still don't understand very well how this works. Like how is it possible that they change the functionality of what happens on the compiler? Because what's happening here is that this string here is not it's not going to be a char pointer as far as I understand. From the compiler's point of view, which it usually is on C++, is going to be a class that they designed to be more optimal, which is a string format or like a variation of the string class. So they have a string class, which is the main class that they use to build strings, and then they have another class which is optimized for this kind of situations where you're just trying to pass the string as an argument to a function. And because they use these classes, then when you step into, it calls functions from these classes, which are functions that they were overloaded. So every time you pass something as an argument to a function, what the compiler is going to do is copy that stuff. Unless you pass a pointer, then it's just passing the pointer. But if you pass the value, then the compiler under the hood copies. And when you create a class and you overload the copy operator, then it runs that custom function that they have. And the reason why is because of memory optimization. So this is one of the classes. So it's just implementing their own copy version. And this uses scout data, which is another class that they use inside the string to manage the data from the string. So they're just copying the argument there. The thing that I don't understand very well is how is it possible that they change the compiler behavior? How do you determine? because there isn't anything on the type. Maybe I think it's the type of the function actually. Yeah, yeah. So now I get it. Yeah. So because the type of the function has that string, then it uses the overloaded operator. Yeah, makes sense. So because this class here is a string, then it's gonna use the overloaded operator from the copy there instead of doing what the compiler normally does. And this also runs, is part of the memnew thing. Memnew is the macro that they use. Then they overload the new operator, which I talked about before, for the customization of memory to make it more efficient. And then this runs, and I think that's, you can put whatever functionality you want here. If you want something to happen after you build the class. So the rendering context is a member variable of the display server windows. And now that I think about it, maybe I wrote the wrong thing there. Oh no, display server. So is this one that is going to initialize, I think, Vulkan. So Vulkan initialize is going to be from the third library that I talked about. So so the actual Vulkan library, which is the same pattern that, so if you go on the source code of GFW, which is the library that is usually, actually I'm not sure if it's GFW. Maybe it's Raylib. Yeah, it's probably, I don't know if it's GFW or Raylib, but somewhere on the source code you're going to see the same thing for OpenGL, where they use a Windows function to load OpenGL, which is a DLL, dynamic linked library. And it's the same thing here. So the actual Vulkan thing is this DLL here. And the load library A is just a Windows function, if I remember correctly. Yeah, it's just a Windows. And then it saves the address on this variable here, I think. But this is from the third-party library. And this is another Windows function to get the process address. So you initialize the dynamic linked library, which is going to be in a different part in memory than your application is. So I do think that it opens a different process based on the name of the function. So the dynamic linked library is another process, and then it gets the address of the process. So it's kind of like pasting together the code for the library into your own application. And then here it's going to have, this creates the pointers in the same way that OpenGL does to each function in Vulkan that does the stuff. So it's the bridge between the CPU and the GPU. So the GPU is the interface through the GPU is the Vulkan library. So like they say that it's closed source, but I think it's kind of like closed source because you can't really see the source code. You just have access to the functions, but I'm not 100% sure about this. Blah blah. I don't think it's here. It's on the next one. There's gonna initialize everything. I want to show the macro there. Yeah, they use this other struct here that they build. So yeah, so they have different types of vectors. Like I said before, instead of using the standard vector, they create their own struct, which is the vector struct, because they're optimizing the memory using the memory pool. So, and I don't know the nuances very well because I didn't spend a bunch of time on each specific function to understand exactly what it does on memory. But because they're using their custom way of dealing with memory, instead of using the standard library functions, they create these custom classes that overload a bunch of functions and that have different ways of managing memory to optimize how Vulkan is gonna deal with everything. So this, as far as I understand now, the title local vector is just a different type of vector because of the memory that they store everything related to Vulkan on. It's just this class here. So there is a explanation here, I think. Yeah. If tight, it grows strictly as much as needed, otherwise it grows exponentially. So I guess they do it like this on the Vulkan because a lot of this stuff is gonna have a fixed like size and it's not gonna take too much memory. So in order to optimize, they create this custom class and then most of the vectors is just gonna be very small. And if you use the standard library, the way that the standard library works is that it has an overloaded operator. I'm not really sure if it's overloaded, but every time that you add something to the vector, under the hood, what's gonna do is just gonna increase the amount of memory. And I think it increases twice. So when you reach a limit that it sees that the vector is full and it's trying to add another element, what it's gonna do is either call malloc or calloc, don't remember really well, and it's just gonna allocate twice as much memory uh, each time. So it grows exponentially the size. I'm not gonna spend too much time. But iterator is another class that happens all the time. So it's another one that seems because of memory. They use this class here to iterate over the other custom classes. So I'm just gonna go over. This is probably on the next one. That's. I'm just gonna step out because I think it's on the next. So here is like the way that usually that I've seen on tutorials and videos that you initialize Vulkan is, and it's usually like this. You have a struct where you have the information of how the thing is gonna work, and then you have the other struct that is actually the thing, and then you pass the two structs into a Vulkan function, and then the Vulkan function initializes everything. So here they initializing the application info, and then they initialize the instance here for Vulkan. Then there's this weird thing that's they're probably saving this, like the classes on the database, like I said before, based on this path here. And this is an internal path, which I believe the editor uses as well to find the classes. So when I go over the editor codes, there is also a lot of this as well. So it's like an interface that you have with the database. Every time you want to call some class or something, you just find the path. It is kind of annoying because I have to remember the paths. And I think that those are the paths that show on the GUI when you're using the editor. They just access a function that it was registered on the class DB class, and then it's gonna call it whatever functionality you set up there based on these macros here. So I believe that this is just getting the configuration, which is probably the config file they have. If you want to have a preset, the predetermined set of like configurations on the pipeline or other stuff like this probably. And it probably, there's something on the editor as well that is gonna save this config file. So these two things here, and then so in Vulkan you also have this other thing which is called layers, which if you want, so it's similar but it's different than OpenGL. OpenGL, what you can do is just call a function in the beginning that is gonna determine whether OpenGL is on debug mode or not. And if it is, then it's just gonna show some messages depending on what kind of step of the pipeline. And you can also have gel print error or gel error, something like that, which you can put anywhere you want. But in Vulkan, it's kind of different because it's similar, but the way you do it is just by setting up layers, It's pretty much the same logic. So when you want to have the debug version, you just set up these layers, and then they're just gonna show more information as far as the sun of what's going on. But I'm not too interested in these parts because yeah, for now I'm not even gonna spend too much time trying to understand these things because my main priority is to build something. So I'm just trying to understand the engine on the low level so that when I change the editor, I have a clear mental picture in my mind of how everything's connected. So it's easier to build everything. So this is the function, is another function from them. This is not Vulkan function. But I think on this function is just passing the info in the instance, and then it's gonna call a Vulkan function. And it's on that this one that is gonna. So I'm just gonna press F5 because it's gonna get here. Is this function that is gonna load everything if I remember? So they get from this Vulkan hooks. Oh no, it's this other one. So this is the function from Vulkan that creates the instance. So you pass the info and the instance there. Let me see if I can find the picture. Because I always forget the amount of stuff. I think I remember now. Like, not that I forgot. It's just that I think that there are more. Maybe it's the application that I'm forgetting. But yeah, I remember this thing here. So it's just the application is the main one that they initialized there before. Then the application connects with the instance. The physical device is just the GPU that you're gonna select, and it's gonna capture. First, you call a function on Vulkan that is gonna get the amount of the GPUs you have that support Vulkan. Then based on that, you put your own logic to select which one you're gonna use to render. And then the abstraction is probably the logical device that you interface with the physical device. Yeah, with set properties. And then the logical device has the queues, which are the lanes, which I explained. And the command buffers is going to be just a buff. Is the same thing on OpenGL where you use GL subbuffer data or GL buffer data to allocate data in memory that's going to be used by OpenGL to draw stuff. So Vulkan, same thing, I think. But you use command buffers and you put them on a queue because you can do the kind of multi-threaded kind of thing where everything is running parallel and then you're synchronizing everything. I think this is evolution of everything, like I said before, because usually, pretty much always, you're gonna have like a relative polarity, and then the convergence, the flow of information is just gonna be the relationship of that relative polarity. So everything's always gonna converge towards the frequency of computation that perceives the relative polarity. So in this case, you have the double buffering technique before, which is the polarity. So either you have the image or you don't have. And now it's moving to a gradient, which is the swap chain. So the flow of images, and that optimizes the efficiency. But then it increases the complexity of information because you, as a byproduct, you have the synchronization. So I think that's just the evolution of time itself. And this is where it's going to load all the pointers in the same way that OpenGL does, just calling this other function to get the address of the DOL that it loaded later, before, to initialize the Vulkan API. Just gonna sleep. So here's not calling physical device yet. It's just setting up the functions on Vulkan, if I remember. I probably put the thing is that I don't remember if I removed the breakpoints. I had to remove some of them, so I don't remember which one I removed or not. But I should have the breakpoints sure on the place that it creates the physical device for the first time and where it filters everything. So I'm gonna step out. So it's probably this one. Got physical device. Yeah, but the thing is that now I don't remember if I. So I'm gonna see here because what they do is they initialize another struct on the display server, if I remember, which gets the device information. And this part is the one that one of the parts that I wanted to review because I thought it was kind of confusing. So first they capture the information for each GPU that you have available on a struct from one of the classes that they have. And then later they use this struct that is from their part to select which, based on the score, which one is gonna be the one that is used to render everything. Then once they select the one that is gonna be used, then they call the Vulkan functions to initialize the physical device. And that's the one that is actually gonna be used by Vulkan. So this, I'm pretty sure, this function from Vulkan gets the amount of devices you have available. The system. So I think I haven't passed the stuff yet. So they're storing on this variable, and then they're looping over. So first it gets how many devices, physical devices you have, how many GPUs, then it's gonna loop. So this is the function that I was talking about. So it's gonna use this struct here, which is the device struct, to store the information of each GPU. So the name, the vendor, and the type. And then later it's gonna use this struct here to select what GPU is gonna use to initialize the physical device. So here's just running through all of them. And then each physical device has these queue family properties. And queue family, I don't know very well what's the relationship between each queues and the queue family, but it's kind of like an abstraction that is gonna connect all the queues that you have with the physical device. So I think the queue family is just probably the abstraction, like it's like you're connecting multiple different queues through an abstraction to one physical device, because you can have multiple devices you're using and like more complex application, I think. So each physical device is gonna have its own queue family, and it's probably useful to have this abstraction because there are some situations where you have to synchronize between different devices. So it would be a lot harder if you don't have the intermediate between the queues and the physical device. But I'm not really sure about this. So here you can see the GPU that I'm using, AMD Radeon. I think I only have one that's is selected. So probably this one gets the physical devices here. I don't understand this very well because like it doesn't make a lot of sense to me to I think actually it does. So probably what's happening here is that like this is 0. So I was gonna say that it doesn't make a lot of sense to resize if this is 0. But I think what happens is that if you don't resize, then it's just gonna be a random place in memory. So when you resize here, probably is like a or maybe it's because it was here. But that wouldn't make sense because then when this runs, it's not gonna run this. So I think it's probably that is happening. So probably this is initialized as a null pointer. And then we resize here to be 0 instead. There is some stuff that I remember either in the documentation or some video that they talk about that they initialize with, you have to initialize the class, otherwise you get undetermined behavior, because if you don't specify, if you don't initialize everything as 0, then the class is just going to be on a random place in memory. So here they're probably saving everything, like all the physical devices on this thing. And instead of using the count here. And they use this one to set up the queue family. So I'm just gonna go here. Now this is the struct, which is probably a part of the display server. No. Maybe this isn't the correct place, I think. Or maybe it is, not really sure. So it's 2 different classes. So, but I remember, so let me see. So this is on the context driver. So the instance is going to be on the display and the physical device is part of the context driver. So it is initialized. So here is not initialized as anything. And storing everything on this tight local vector thing. So it's probably, they're probably using tight local vector because of this. Like this is one examples, because it's gonna be a limited amount of devices always. So it doesn't make sense to grow the thing exponentially if you don't have many devices. I do remember that there's somewhere that they say that you could store on other data structure, but vector is more convenient. I don't remember if it's from Godot or somewhere else that I seen this. This is the struct that they use to interface with the Vulkan thing. So when it's creating the pointers based on the DL on Vulkan, it's using this struct to call the Vulkan functions from this class. So maybe I thought about it the wrong way, because the first time I remember that I was thinking that the struct that they save everything is part of this class, but apparently it's not. Maybe it's part of this and the pointers. Oh, so it is. So when I press F12 there, should go to the definition, it's going to the wrong place. This happens sometimes with VS Code. Also, when you step into, have to be careful because sometimes VS Code goes to the wrong place. It's kind of confusing. I trust more, and I'm pretty sure that it is correct. So when you press F12, I think that there's a higher chance that it goes to the actual function definition that is being used sometimes instead of when you're stepping into, but that apparently can also be incorrect. So I assume that it's saving everything on this structure, but maybe not. This is kind of the confusing part because it doesn't have the variable, but it is declaring the variable using this struct here, and it is declaring that that's inside of the function that is from the other class, which is the derived class from this one. So I think it makes more sense that it's using this struct here, this version. Let me see. It's worth it to spend some time because like he's gonna use this later to select the physical device, so I wanna understand. It's definitely the one that is part of the class there. The one that's the base class of this one. But the thing that is kind of weird is that it's not using this anymore. So like it's initializing here, the pointer, and then it's just not using it anymore. So that's kind of the weird part. Oh, I guess it's just a pointer to this driver devices here. Oh, so I understand now. Hmm. And this is kind of weird. There's something that I don't understand very well here. Because like now I just realized that's the part of confusion that I have. So probably what's happening is that this is a pointer to this thing here. So actually it is stored because, but now I don't know if it's gonna be. I think it doesn't make sense for it to be on the stack because then it would have a dangling pointer. Because then the compiler would maybe not actually. No, when the function goes out of scope, the pointer would point to nowhere. And so the driver devices, the driver device is part of the class. So it's just with the memory of the class. So I think that this makes sense. So because this was initialized in the way that they initialize the other functions using their own custom memory allocator thing that allocates the class on the memory pool, this is the address of the function. The address of the class is going to be inside of the memory pool, and the member variable is going to be together with the class. So when they create the pointer there, they're just pointing to that place in memory. So this, even though it's initialized here, is just going to be a pointer to this. But the thing that is kind of confusing is that it's looping over the physical devices here, and it's not initializing. It's just resizing to the device count here. But I don't understand why this gets the device. That's kind of the thing that is weird. Because it would make more sense if this was physical device here. So it has to be because of this thing here, I think. So, and it's kind of weird to understand, but I assume that this is what's happening, not 100% sure. But I think when they resize here, it connects this variable with this. So when they pass here, it increases the size of this one. And because of that, you can loop over here and get the index of each one. And then it's populating the index of the driver devices with this thing that they initialize here, which is going to have the properties of the physical device based on the props here. So it's storing everything on this struct, which is going to be inside this tight local vector. That's a member variable of the thing. And the reason why I can access the index is because it resizes here to this value, which is the one that's used on this function that gets how many GPUs you have. I think that's what's happening, but it's kind of confusing. So the driver device is the thing that's going to be used later on to select based on the score what kind of thing is going to be used. So I'm gonna write, actually I'm gonna go to the definition first. But this is, again, is VS Code going to, so what I have to do is just code this. So it's going to the harf bus. Harf bus is the external library that they use to render text. You just have to go here. So it's gonna be this class. This is local vector. So this is just a specialization of the local vector class. Just a templated class. Don't remember now. So this is the function. So they are passing the physical device thing there. And this, I guess, is the template in the class used to initialize the class. It's gonna be uint32. So this value is the physical device count there on the other function. So count, I assume, is gonna be 0 at the beginning. Yeah, 0. So that's the question, is piece size. No, it's not gonna be, it's gonna be the same because So it doesn't do anything. That's kind of weird. Because count is 0 and piece size should be 0 because they initialize a 0 on the device count. So I don't understand why, like what is going on. If it's not going to either one of these conditions, it doesn't do anything. Just kind of weird. It's probably because, oh, I'm dumb. It's because of this thing here. Yeah, now I understand. I was confusing the functions. So this is the one that gets the counts. So first they initialize, that makes a lot more sense. So they initialize, they get the counts of how many things it has. Then it's not going to be 0, and then that's how, now it makes a lot more. I was confusing this function with this one. So this one gets the thing. That makes a lot more sense. I guess it's the same function. So they're just calling the function twice. Still kind of weird. And now I'm thinking if there isn't a way to just call the function once and then. So the reason why I think that they are doing it like this is because like they are passing the pointer to this one. So it's just gonna. I think I don't know really well like what happens inside of this one. But I think it's just gonna connect this vector here with the instance. So first to get the counts, then you resize all the vectors. It's probably because of the memory, like obviously, but I wonder if there isn't. Yeah, but it's whatever. So now I understand. So they're getting the counts, then they resize all the vectors based on the counts, and then they loop over how many, and that's how they're able to access here. So here, this vector here doesn't have anything. Initialize everything to 0. So all the values are 0 in the beginning. It just has the same size as the amount of GPUs it has. So the physical device. So here is initializing. So it's storing the device struct inside of this vector here, I think. But it's still kind of confusing. Because it's using the address and not the pointer. I think that's what's happening. So it initializes the address of this thing as the address of the device, driver device on that position. And then when it does that, it's initializing the struct inside of the vector here. So it's gonna store everything on the driver devices, which is a part of the context in the beginning. So I think I understand. I still this thing. This thing I think it makes sense because of it's passing the pointer here. So they're probably connected with the instance because you pass here. But I have to remember how this one works. But I imagine that this is what's happening. This is probably storing some information about the physical device on this vector here, which is connected to the instance. And yeah, the physical device is also a member variable, so it makes sense. Whatever. I think in the beginning that's all the main parts. So you should probably press F12, F5 to go to the next breakpoint to get to the editor stuff. Oh, also this one actually. So this is the first one that is gonna create the window. And I think it calls stuff from Windows to actually create the window, obviously. Or maybe it was this one that's no, it's right here. So just some member variables to determine the style of the window. Also is getting the amount of monitors I have. Just kind of obviously makes a lot of sense. I still don't know how, like the logic, how does it work? For example, when you're moving let's say you open the application one window, what happens when you move to the other one? It's kind of, I don't know very well how that works. So this is the main function probably. It is from Windows. It's gonna create the window. Or maybe not. No, I think is that one, but there's other functions like behind the stuff used on the other one. Actually, I'm not really sure. Oh, I think it's just pass. This is probably from Windows. So this creates the window. Yeah, it's a function from Windows that creates the window. And then later, yeah, it stores this on this class, which is the display server. Display server Windows. So here it creates the surface, and this is a different class. So the previous one was a function from display server Windows, and then this one is the function on the context driver. And this is the one of the functions that I mean in the like before. That's so it's going to use these functions from Vulkan to create the information and then to create the instance here of the surface and gets the instance. So the instance was saved. But then after it does that, it calls this thing here. And the way that this is constructed is by using the define macro inside of the display server window. Or maybe it's, yeah, inside of this one, I think. Now I don't know very well. But I think that this is a way that they connect the... this part is the one that I said that it's kind of confusing. So I want to see how they get. Also, they are saving the instance also on this class. I don't remember where this happens. Probably on the physical device there thing. Yeah, I think on the physical device. So they initialize the instance on the other class, display server, but they probably uh, initialize on this class when they're doing the physical device thing. So they just reassign the value of the variable there. Also, it's not showing. So maybe it's not on this one. Yeah, I'm not really sure why it didn't show there. So I think this one is different, but it's a similar thing. So it's on other instances that is gonna do that. Yeah, because this is still on the is rendering context driver. And this is the base class of the other one that's using there. So this one is different. Just gonna skip all this stuff. I want to see if I can find the other ones that initializes the stuff on the with the macro there, so I can show. Probably this one, the rendering device thing is gonna have. So this is what I mean is that based on the theta thing here, it seems that it's not supposed to be defined, but it is an IDE thing because it is actually defined. It's gonna go over this if I remember correctly. I put the breakpoints there as well. So that one is initialize the window, this show window here. So it's initializing the rendering device there. There is some function when you initialize the shaders that checks to see if the class is the owner of the shader. The way that it works with the RID is that it's just resource ID, and it uses the resource base class to manage the resources, and then it's going to use the class when it's creating the shader. So the resource class is the main class that is used to manage all the resources, the text related stuff, the texture, and I think the materials classes or something like that inherit from these classes as well. And so the rendering device graph is a member variable of the rendering device class. And so some classes they do this. So based on the way that they do the initialization there, some classes use this uh, extra functionality after you initialize everything. And I believe I haven't looked into the nuances of how these functions work, but I think that they basically save the class on the database on the class DB. So that's the point of these things here. And uses this macro there too. So I think whenever you put the GD class here inside of one of the classes, the macro is just gonna store the class on the class DB, which is the one that is used by the servers to um, communicate with GUI elements, I think. Like serve as a, I think it's a messenger uh, pattern, design pattern. Whatever. So this is the so here is going to use the part of the function there that I wrote down here. So it passes the context driver to this function, and then it makes it equal to a member variable of the rendering device, which is the context variable, and then it calls that driver create and stores the driver, which is this class on this class, just connecting them through this function here. So the p context is the context driver from before. Actually, it's this one. This one. Yeah, makes more sense. And then here is gonna change. So actually, so here is gonna store that class on this one, the rendering device. And now I don't remember really well like how it uses this before. And so this was stored on the display server. Yeah. So it's creating different places in memory for the same class, I think. So when it initializes, when it makes p context equals context, I think what it's doing is just changing or creating a pointer to the same place. That's what's happening. So the context is a member variable of the rendering device, and the p context is the one that it was initialized as the member variable of this one. So the display server Windows has the rendering context driver as a member variable, which is the rendering context, and then it passes that to that function that's just looking at. And then it makes that the variable inside of the rendering device, which is the context variable, to point to the same rendering context driver. Yeah. And then it calls that driver create from this, and this is the one that is gonna initialize the rendering device driver Vulkan, which is the main class that has all the functionality to create the Vulkan graphics pipeline. So this one is the one that stores the device. So I think a little bit later is gonna, maybe on the same function, is gonna select the devices that it is stored on that struct before, on the device struct. So let me, this is the part that is kind of weird. Maybe I wrote the wrong thing here. Oh, actually, yeah, I think I wrote, because the struct is actually from the base class, which is the rendering context driver. So I think that makes more sense. So first it puts everything on the driver device here. That is from this class. Then it uses the information that is stored here to initialize the physical device on this class here. So I think it does make sense that it does like this because of the abstract class thing. Because this is the base class, so you don't know which driver is going to be used. You store the information for the device on this class first, and then use this to select, depending on what kind of driver is selected, to initialize the physical device on the selected driver class. Yeah, so this is the function, I think. Yeah, that's the function. So here is gonna, but it is kind of confusing because it's a function from this class here, but the thing should be on the other. That's the part that is confusing. So let me think about this. I'll be right back. So this one makes sense because it's getting from the context. So let me. So the device is on the context. Oh yeah, that makes sense. I was confused for a second. So yeah, makes sense. So based on the information that is stored before of the device on the thing, these functions are probably gonna get the it gets from the driver devices, which so now I understand it. This part was the confusing one for me. Because the first time I was going through, I forgot where the device was stored and what this thing was. So, but now I get it. So just getting the values that stored on that struct from this device, from the context, which is the rendering context driver, which makes sense. And then based on this, it's gonna so it gets the vendor and this stuff, and then it's gonna call this function here, which is the option score. So here is just keeping track of which one is the highest. So I think initializes. I initialize at 0 here, so and checks the score based on this. Interesting. Yeah, so this is the way that they use to determine which one is going to be used. It's based on this enum here. Device type integrated, discrete virtual. So the integrator is the highest, lowest is other type. And I guess this is all like enums that are parts of the Vulkan. So is the type that you got there on the previous function? It doesn't have anything here, so maybe it's not related to. Yeah, but it has to get the type from Vulkan, so it is a Vulkan thing. But then obviously you can select the order in whichever way you want, probably. So I think I only have one. Then based on this index here, later it's going to use this index to. So it stores the index of the one that was initialized, which because it's going to use the driver devices there to get the thing, probably. Yeah, so it passes the index to the context, and that's how it gets the device, which is struct device struct. So this is from the. So if I remember correctly, I'm not 100% sure, but I think when you initialize the values like this, it's different than initializing them as a member variable. It's like a similar to a static variable, but I'm not really, I'm gonna ask this to ChatGPT. Not really sure what's the difference. Now I'm not really sure what the static version would be. Maybe it is just a member variable because yeah, I think it is actually yeah. So I was wrong probably. So the reason why they initialize like this is probably because it is inside of the class. Like the initialization, the declaration of the struct is inside of the class. So it's similar to namespaces. It's just accessing the struct. Yeah, I think it's just a normal member variable. But I do remember something related to that at some point that I seen. So I don't remember really well what's the. Yeah, whatever. I'm pretty sure that this is the function that is going to initialize the physical device. So it's just initializing the, it's just storing the information of the device on the other class as well. And now, what is the best way to just say this here? This is gonna be kind of confusing if I put there. Oh, but the thing is, it doesn't store the type here is wrong. Right. I have to change there, I think. Because it's a vector. I'm probably not gonna be able to go over the editor codes. So it just gets the device based on the one that it was selected with the index there. I think here is one of the classes that's one of the functions that I wanna, and maybe it was inside of these ones. Alright, so same thing. Context driver is gonna be the other class there, the running context driver class. I assume that since I didn't put any breakpoint here, it's probably not very interesting. It's just gonna initialize everything on Vulkan. Yeah, I'm just gonna skip this. Pretty much the same thing. It creates the struct, the Vulkan struct, gets the info, then it creates the instance. Here's initializing the functions, I think. So initialize the functions, the Vulkan functions, which are pointers with their external library there, and then it's saved on the rendering context driver. And now it's just saving them on the derived class as well, I think. Because it's gonna use these functions later to create the pipeline. So yeah, just initializing these things. Same thing here. Allocator is related to memory, so. But I haven't paid too much attention to the memory thing yet. From the Vulkan side. Oh, so this is one probably that is gonna show there, the macro. So this is what I was talking about. That's why it's kind of weird there. So this one, if I remember correctly, is on the rendering device. Yeah, rendering device driver, which is different than the rendering context. So I don't understand very well why they are doing like this. Like I don't get the initialization, but basically the way that this works is that you call this macro. So it's pretty much initializing a struct with this name here, and then ID pasted after. So be like this name. That's what this does, the macro here. Because this is a token pasting operator, which just means that it gets two tokens and then paste them together. And this one inherits from this other class, ID class. So I guess it's because of the constructor of this thing here. I don't understand very well how the. But if I step into it, then it's gonna show there. So this is because I don't understand the functionality here. So as far as I understand, always in line, it means that it's gonna paste the functionality whatever you declare this thing. So this makes it faster, I think. So like one of the obvious reasons to do this is just because if you don't do it, then you would have to declare destruct again each time based on the different names here. So it just makes it easier. So this macro series is equivalent of the declaring destructs inside of the rendering device class with this functionality here. So if I step into, it initializes the ID, which is the struct that inherits so this thing here. So it's using this constructor and just passing the ID here. So the thing is, what is the ID passed? Yeah, that's the thing that I don't get. I guess it's passing the value there. So maybe it does make sense because it's gonna initialize the class with the stuff that initialize outside. I'm gonna show. So the argument here is what is passing when you initialize the thing. So this PD here. Yeah, this is this stuff here. So I think it does make sense now that I think about it. So this is gonna be that argument that goes on the ID. So probably that's the reason why it's doing like that. But it's just storing the ID, and this stuff here is related to the Vulkan thing. Yeah, but this example is not very good to understand. But basically, they do the same on the other ones. That they call Vulkan functions, and they create the Vulkan structs, and then they call Vulkan functions to put the specification. So here they initialize the Q family, which goes on the physical device that I talked about. So they're just gonna use Vulkan to create create specifications with the struct of how the memory is gonna be used to draw. But then they call this thing here, which is on another class, and that's the part that is confusing. Because the context driver is not from this class. It's the rendering context driver. And the physical device is from this, I think. Yeah. So they're variables from different classes. And now I don't remember which one is the one that holds the physical device. Maybe it is the rendering device, but whatever. Because so the way that I was thinking about it before is that they use this as a way to bridge the two classes, but I don't think that makes sense. I think it's just initializing the struct and returning the struct with the index that is based on the on how they created using Vulkan. So so I don't understand very well why I do things like this. The physical device should be on the it is on the rendering device driver Vulkan. So it is on this class here, I think. The next time that I go over, I have to write this stuff down. But I do think that makes sense because it's not declaring this everywhere, so it should be. I should be on this class here. I think maybe I wrote it down here. So the question is, why did they use there? Why did they initialize the class like that? Like they struct inside of the other class? And what is going on when they do this here? I guess I'm just confusing the things. I think I confused this one with the context. So I think it does make sense actually. Because this one is just gonna be inherited from the rendering device, I think. Yeah, so that's the reason why they can initialize here with that thing. Let me see. So I think it makes sense now. I was confusing this class with rendering context. That's why I didn't understand how it works there. But now I get it. So like they declare the only weird thing is the way that they are declaring the struct inside of the other class. So they're using the macro to declare the struct inside of the base class, the base abstract class, and then they return the initialization of the struct on the derived class because the functions are called from the derived class. So I think it makes sense. And then they store the variable on the base class. So it is kind of confusing because of the inheritance of classes, but I think it makes sense. No, the driver is from the context. So maybe it doesn't make sense. Then how? Yeah, I don't understand. Oh no, no, actually I don't understand. No, it's using the context to create the driver, which is rendering device. Yeah. So I think it makes sense. Yeah, it is the so this is the part that I'm confusing because I probably the last time that I saw this I uh, confused this rendering context driver here with this class that has been created here because of the way that it is. So this the driver is actually going to be the rendering device driver. So it's just weird that the way that it is weird, but it makes sense, I think. So they initialize it. It's weird because they are making a member variable on the base abstract class that is equal to the derived class of that base class. That makes sense, I think. Because I think that this one inherits from the rendering device. Yeah. Well, maybe it's not the same thing. Yeah, so I think that I'm getting confused because of this. But maybe this is the base class of all of them. No, it's a different thing. So it's confusing because of the names. So I think because of the name, I thought that this is derived from this one, but it's actually not. I think there are two different things. And that's the reason why it initializes this one as a member variable of this one. So I think that makes more sense. But it's still very confusing because of the names there. Yeah, it has to be this because it doesn't show there. So I think this is what happened. Like it's a lot more clear now in my mind. So it's two different classes actually. So it's using that to connect them and is initializing them with the ID. But then, yeah, so the function is from the derived class of this one. Oh, maybe not actually. But if it wasn't, then how is it possible that it's gonna call? Because this one is from the rendering device driver. It's going to another place. This is the wrong place. I guess. Okay, so here. Oh no, it's not. I'm confusing. So it is not from the base class. It is declared on the class itself, on the driver itself. So it's connecting the structs that the weird thing is the way that initializing, but I think it makes sense now. So it's doing like this because it passes the ID there on the initialization of each one, and the ID is connected to the Vulkan API, to the way that initialize everything on the Vulkan API. And then it returns these structs on the other functions and assigns them to the member variables of the rendering device. And it makes sense because they are not on the same family uh, tree of classes, let's say. So I think the most confusing part here is the names of the thing, because that's probably what I got confused by, because I thought that rendering device was a base class from rendering device driver Vulkan, but yeah, I guess that yeah, and it isn't. So it's just connecting the true with the and the values that it's using to initialize the stuff on Vulkan itself is from this class, I think. It's not from the other one. So it uses this class to initialize everything on Vulkan, and then it uses these macros to initialize the member variables on the other class. Yeah. But I don't like this very much, to be honest. It's very confusing. Which makes me think that there's probably a better way, but it's probably too hard to change everything. So I'm gonna stop streaming now because I'm already tired, and I'm just gonna keep stepping over everything. So I wanted to go slow on this part because of all this confusion that I just explained now. So I wanted to clarify everything, but yeah, I'm already tired, and like I was gonna take a break now and keep going, but I think it's better to just step over the editor again. Like off stream, and then I continue tomorrow probably. But now it's a lot more clear. So the biggest thing the two things that I didn't like is the names. It was very confusing, and also the initialization here, like it's kind of confusing because I don't understand why they do things like this. So here, this is what I mean is that, but here is not initializing any member variable. I think from so you just initialize everything on the function. So it's not actually any member variable of the rendering device. Just using rendering device driver to initialize the things on Vulkan, and then it's initialize the struct inside of the So the question I have is why not put the structs on the rendering device class if there isn't anything related to rendering device driver Vulkan here? I think that's the thing that doesn't make a lot of sense. Because if you're initializing everything on the function and nothing, they are not related to the. Because the explanation would be that like there's some variable here that needs to be from this class, and that's the reason why this function is from this class. Or the other explanation, I guess, is that this function is used later, but it doesn't make any sense, I think. Because you're creating everything you're going to need on this function here. So the only thing that makes sense is that this class is going to use these structs at some point, and that's the reason why you put the macro inside of this class to initialize these structs. Because in my mind, it makes a lot more sense to put the macros on the rendering device if they're not related, and then just call the function from the rendering device class. I think it makes it easier to understand. But it's kind of tough because I don't know. Like they obviously they have a reason. I just don't understand. It's kind of hard to understand the place that they are coming from there. It's probably there's other stuff like along everything that's or based on the way that things evolved. They did things like this, and it could be possible that you can change, but maybe fucks up other things somewhere else. So it's kind of hard to know. Also, this is another part that is confusing. So it isn't that from this function directly, from this class directly. It's from the class that this inherits from. Yeah, which is rendering device driver, which is different than rendering device. So yeah, it is a base class of the other class, but they're not connected. So I confused this rendering device driver with this one because I thought that I just confused the names. It makes sense, but I don't like it. Just connecting the values based on this with the rendering device class. Or it could be because of this. But it's still. I was gonna say because it could be because of the RID here, but I still don't think that makes a lot of sense. So rendering device. So I guess they are from the same family, but they are different branches. So they are on the same level. They inherit from the same class, which is rendering device commons. But rendering device driver probably like is a different path. I don't understand why the declaration there is different. Right? Like what is? I guess it's because of the namespace. On the other file there is a namespace, I think, like RDD and then the namespace. Allow them to access the struct is the same thing on the other one that are confused with the static initialization. It just allows them to access the namespace of the class. I still don't see the point of doing that. The only point that I see is with the macro to not repeat the initialization. But I don't get why they're doing that on the other class instead of the rendering device class. Unless they're probably missing something, but don't see the point. I'm gonna stop here. I'm gonna continue to go over this off stream, and probably tomorrow I'm gonna continue to step over this. So tomorrow I'm gonna go faster because I already, or maybe I'll go over this. I think I'm gonna go over this again off stream to after I take a break to clarify even more. But now it's a lot more clear what's going on there, the part that I was confused about. And then next time, probably that I stream, I'm just gonna try to press F5 as much as possible until I get to the parts of the editor. And the main thing that I'm gonna try to do is just to comment out stuff from the editor to see how it changes the GUI. So yeah, and I'm probably gonna go back and forth between like bottom up and top down to clarify how the whole pipeline works. So I can, yeah, I'm not really sure. I have to think about this, like whether or not it's already worth it, because maybe I already have enough knowledge at this point, like enough for the understanding of how it works, just to read the docs and create a module, for example. It's not very hard to create a module. So I'm gonna spend some time thinking about, because I have to clarify what is the best. Yeah, I think I have to understand the editor first, because the main thing that I want to do is to draw stuff inside of the viewport from the editor initially. So there's two main things that I have to clarify. One is how to draw stuff inside of the viewports on the editor from the code from C++ directly. We without having to interface with the GUI, with the editor GUI. And the other big thing that I want to clarify is what happens is like how do you save the game, which is, I think is on the export button there, but from the editor's point of view. So I can also do that programmatically, because the idea that I have is to programmatically create the game if I want to, but also have the option to use the editor if I want to. Use the GUI to debug, for example, or other stuff like this. So yeah, I want to be able to change the editor code so I programmatically create the visualizations inside of the viewport. So I have to understand first at what point of the editor it creates the viewports and how to change the code so that it draws stuff. And probably that's going to involve all the other parts of the editor as well, because they're all connected, obviously. So, and then after this part, I have to understand how to programmatically export. So and understand how the data is going to be, like how Godot's going to use the path that you pass there to load the data and change the configurations, which is probably on the project settings class and on the config file, in order to determine what the engine is going to show, which is going to be, like if you're loading your app, I have to export actually, because I haven't done this, to understand what is the final executable that actually loads the game you create and not the editor. That's the point of confusion. Because I have to clarify how to programmatically create the executable that creates the game. That's what I want to do. Yeah. So I have to understand how I have to clarify the editor a lot more probably. But I'm gonna try to comment stuff out and see, because I think that's a lot better to understand than just stepping over. So tomorrow I'm probably gonna press F5 as much as possible, or like turn off these breakpoints here until I get to the editor, and then just comment out a bunch of things and see how it changes the GUI, and try to clarify the stuff that I'm confused about. So yeah, probably tomorrow